Well, hello again. We're going to talk about the law of cosines today. And if you look at this, you can see again there's three versions of this. This is always in a textbook like this. And the important thing is to not get all fixated on the letters, but to see the patterns. And we're not going to use three equations here. We're just going to learn to use one and to see how the patterns play out. So we have a triangle for reference. We have the formulas. So what I want you to notice here is I call this bookended. See at the two ends here, we have a cosine, law of cosines. See how we have A, and we have B and B, we have C and C. So really the thing to notice here is we have an opposing pair. So we have A with A, B and B, C and C. See, we have opposing pairs, and that bookends, or, that's on each of the far ends of this formula. Now, if you look at this, let's just take this formula right here, this version of the formula. So notice that there's only one angle. You use all three sides and only one angle. So I have angle A in this particular case. The side opposite has to be by itself on that side of the formula, on that side of the equal sign. And then the other two sides, the B and the C, notice how those are the ones that A is in between, right? So these are like side, angle, side. So those two sides, it doesn't matter which order they go. Addition is commutative. Multiplication is commutative. So really what we're seeing here is you focus on the angle you're interested in, and then this letter over here, that is the side opposite the angle, and then these two would be the other two sides in any order. So it's, well, let's just run through an example. So notice the pattern. If I go with B's from angle B, the side opposite is by itself, and A and C go here and here. If I'm focusing on angle C, then the side opposite it is by itself. And then these other two, A and B, notice how that's working out. So let's collapse this down to one version of the equation. And let's look at this more, how it would play out with a problem. So just to make it a little different, let's do an obtuse triangle. Suppose I tell you that this is 135, and let's see, what do we want to solve for? Let's solve for this, right? So if that's side A, let's call this 10 inches and this 14 inches. And to start out, all we'll do is find side A. Okay, well, first of all, notice that I cannot use the law of sines. You don't got to try to memorize when you use it. The law of sines is nice to use. It's short and sweet. Let's try to use the law of sines here. So if I tried to do that, I'd have this pair, A over sine of 135. And then I'd have to pick my poison. So I better label these angles. So let's say I wanted to go from B. So then this would be sine B over 14. See, I've got too many unknowns there. You might say, well, go with C then. Well, if I did that, I still have too many unknowns. See, so you don't got to memorize this. It's just if you try to use the law of sines, it's not going to work out. So let's use the law of cosines here. So here's the law of cosines. You start with your angle. So this would be cosine of 135. Now this side, this letter, this side has to be across from it, and that's what we're trying to find. Now this, it doesn't really matter what you call B and what you call C or what order you put them in. So we're going to put, the way I drew it, this would be 14. C would be 10. And this would be 2 times 14 times 10. And notice I have all knowns except for my A squared there. So we'll get out the calculator. And I'll type this in. Normally I do it in stages. So I'd have A squared, and I do these two right there. So we have 296 minus, and then I'd punch this in. Oh, hang on a second. 10. All right, and this is giving me negative 197.99. So you got to be careful of that because that's minus a negative. So a squared is actually going to be 296 plus that value. So I'm getting 493.99. And now that's a squared, so just at the end you got to square root it. So that would be A is 22.23 inches. All right, so there's our first example with the law of cosines. We'll run through another one. This time we'll make it an acute angle, or triangle, excuse me. Let's call it XYZ. We'll do this as 50 degrees, 20 meters, 18 meters. And we're going to solve the triangle. Now remember, to solve the triangle means we have to find everything we don't know. So I am done when I find angle Z, angle Y, and side X, that would be. So there's always only one solution with the law of cosines. You don't have to worry about if there's two solutions, even when you're solving for an angle. Although you do have to be a little careful depending on the way the picture's drawn. We'll get to that later. Now, we cannot use the Pythagorean theorem, so don't be doing that. This is not a right triangle. So we might try to use the law of sines, but this will be like the last problem. There's too many unknowns. So all else has failed. I'm going to use the law of cosines. So I look at it. The angle's where I start. So this is going to be way down here, cosine of 50. And this one has to be the side opposite that angle. So that'll be x squared. So this is one of these other sides squared surrounding that angle, plus the other one minus twice the product of the two. Got a little squished in there. So you don't have to do this middle step, but I'm going to. 724 minus 462.81. Well, shoot. 724, 462.81. And I'm getting x squared is 261.19. So I'm going to square root that. 16.16. And that will be meters. All right, so once that's done, the way these will work is to get your first answer, you need the law of cosines. Usually, for your second answer, you're going to use the law of sines. And for your third answer, it'll be 180 minus. Okay, so you actually only use the law of cosines one time when you're solving the triangle. So there we go. I found an unknown. This is 16.16. And now that I have that, I can use the law of sines to find either y or z. So you can't find two unknowns at a time. So pick y or z. I'll go with y. So let's see. 20 over sine of y, right? 20 over sine of y is equal to 1616 over the sine of 50. And notice I only have one unknown. So sine of y is 20 sine 50 divided by 1616, and be careful your parentheses. That's 0.948. Now I'm going to inverse sine that, and I'm getting 7144. And in this particular problem, since you were given an acute triangle, I know that that is the acute version of the angle. All right, and then notice I use the law of cosines to get my first unknown. I use the law of sines to get my second unknown. And now that I know that angle right here, all I got to do is 180 minus to get the third one. 5856. Okay, now there's one other scenario. Notice that the givens here were side, angle, side. Those were the givens, and then I found that, found this. The givens were side, angle, side. Now I told you you don't have to memorize when do you use the law of cosines, but you can if you want. You use when given side, angle, side. We just did two examples like that. Or side, side, side. If you don't know any angles at all and you want to find an angle, that's when you use this. And by the way, that would be a very common scenario. If you think about if you're measuring something like maybe a deck in your backyard, you would use a tape measure and measure all of the external sides. You probably wouldn't have a protractor where you could actually measure the angle. You would measure the sides and use those sides to calculate the angle. So that's what we're going to do here. So let's say we have another obtuse triangle. And this time, all we know is the side lengths. So let's go with 41 millimeters, 19 millimeters, and let's go 26 millimeters. And I haven't given any names. Let's go A, B, C. Now, when you're doing one of these problems, there's two things you got to be careful of. One is when you're given a side, 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 you want to find an acute angle first. You wouldn't want to find the obtuse one because that's when you're going to get into the case where you're going to do the inverse trig function, you're going to get an acute angle, and then you got to do the 180 minus thing. It's just simpler if the number that comes up on your calculator is the acute angle you're looking for. So if I was doing this, I would find A or C, not B. So I'm going to find angle C first. In order to do that, I need the law of cosines. So I'm going to go cosine C. See, I'm focused on the angle. That's how I know where to get started. Way over here on the other end has to be the side opposite that. And then these two sides, it doesn't matter what order you go in as long as they're both done correctly. So I have 26 squared, one of them squared, plus the other squared, minus twice the product of the two. All right, now there's a very common error that takes place in another step, but let me get this done. Almost everybody will do this correctly. All right, at this stage, this is not a B, 2132. At this stage, I don't know, 3/4 of all students will want to go like this. Right? We're subtracting those numbers. The problem is that is not true. No way can you do that. And to show you that you can't do that, let's pull this back into algebra. See, I have a number equals some other number minus another number times a variable quantity. So look at this. Is this legal? Can you go 7 minus 3 is 4x and then proceed from there? These are not like terms. This is really cluttered, but this is a variable term and this is a constant term. You may not combine them. Those are not like numbers or like terms. So what do you do? Well, we got to subtract the number over here to get all the numbers on one side. And I'm running out of room here. So we'll scooch over here. Minus 1996 equals negative 2132 cosine C. Now we're going to divide. Notice the negatives cancel. And I get cosine C is 0.936. And now I inverse cosine 0.936. And I'm getting angle C is 20.61 degrees. And that's only one of my unknowns, but that was the hardest one to get. So I'm going to have to do some erasing, but let's just walk through this again. I wanted to get an acute angle, so I picked C. That means the side opposite is by itself. These other two, in whatever order, is 1 squared plus the other squared minus twice the product of the two. I just do a little bit of simplifying. I do not combine these terms. I shove the number with the number, and then I divide to isolate the variable, and then I inverse cosine it. And that gives me my first answer. So remember, we're solving the triangle here. So I'm done when I get all three angles. So I just got my first one. Now, like in the last problem, you only have to use the law of cosines once. We could do this whole thing again for A or B. You'd want to do it for A because it's acute. But you can use the law of sines for your second unknown. So I'm going to go with B because, no, A. I want to find the acute one. I always do that as a matter of habit. So if I want to find A, I'm going to use this opposing pair. And I found C, this opposing pair, because now I know what C is. So sine of A is going to be 26 times sine of 2061 divided by 19, 0.482. I inverse sine that. And that gives me 28.82. So let's see. I used the law of cosines first. I used the law of sines second. And the third one, all I got to do is 180 minus minus. And I never had to worry about whether it's acute or obtuse because I chose the acute ones first. So I have 180 minus 2061 minus 2882. All right, I lost my helpers, so you're going to see me reach over to press stop now on all the subsequent videos. But I hope that was all right. If not, leave me a comment or send me a message on Schoology, and I will get back to you. Take care.